A system concept is very important in physics, and you'll see it again and again, both in force considerations as well as energy considerations. We're going to define a system as something that we're interested in. These are objects. We're going to look at how they can be used to study their interactions. Let's consider Derek, our friend from Veritasium videos, standing on a playground spring animal. In the system schema, we're going to identify all objects that are interacting. And we're specifically interested in Derek. We're going to identify all the objects that are interacting. So we have Derek, and we're going to put all objects in circles. We have the spring animal. I'm just going to identify it as spring. And we always have Earth. And a lot of physicists call it Earth's field. Sort of like the magnetic field concept. All right, so you can call it Earth or Earth's field as you'd like. And now we're going to draw lines that represent interactions, that these lines are both two-way interactions and equal and opposite. So Derek interacts with Earth's field, and Derek interacts with the spring, and also the spring interacts with Earth's field. I'm going to now walk through how to construct a force diagram for Derek. So Derek, I'm going to declare as my object of interest. I'm going to first grab a writing tool, and I'm going to draw a dotted line around Derek's symbol in the system schema. And then I'm going to notice that there are two lines of force crossing the dotted line. We've got the force between Derek and the Earth's field, and we have the force between Derek and the spring. All right, we're going to now replace Derek symbolically with a little dot, okay? And now I'm going to draw with the black line the forces. Earth's field is always downwards. And I'm going to draw it straight down. I'm going to label it with F. And I'm going to say by Earth's field on Derek. I'm going to abbreviate D for short, okay? And that takes care of this force line. And the second force line is the force between Derek and spring. And Derek talked about putting weight on the spring, okay, forcing the spring down, compressing it, while the force by the spring on Derek is going to be upwards. And I'm going to try and draw it the same length as my downwards force. Derek is at rest, and motion is not changing. And so these forces should be balanced. So this is forced by the spring on Derek. Okay, so we're going to always use capital F for force, and we're going to put subscripts or a description of the force by the object and on the object of interest, okay? And I'm going to also add congruent marks just to show that these are hand drawings and these are meant to be the same magnitude force lines, but they're opposite directions. We will say that these forces are balanced. We have an object at rest, has to have balanced forces. Means that the sum of forces, if I were to add up those two forces, it's going to be equal to 0. All right. You could imagine these having a positive and negative value, and if they have the same positive and negative values, they would cancel each other out if you were to add these two up, okay? I wanted to remind you that in the video, Derek drew the force arrows right on his center of mass. And so I just wanted to show you this as a comparison. This looks like very similar to the drawing that we just did over here to the right.